Hello everyone, welcome to my channel. In this video today, I'm going to solve the problem 240th on Leetcode, which is a searching problem with a text of medium. So the problem is very simple. They give you a matrix and also a target value. And the question asks you to search to check if this value is in this matrix. You guys can return a true. If not, you guys can return a false. Very straightforward. And also, they ask you to implement an efficient algorithm. And also, they give you two characteristics. The first one is the row. The value are sorted ascending from left to right. And the column is also ascending from top to the bottom. Let's have a look at the example here. So you guys can see that the matrix the row from left to right is in ascending order, and from top to bottom, that is also in ascending order. So they ask you to search for the number 5. The target value is number 5 here. And obviously, 5 is in this matrix. So you guys going to return a true. And in the second example, they also given the same matrix with the target value of 20. Target equal to 20. And you guys can see that 20 is not contained in this matrix. So it's going to return a false, obviously, right? So when you guys have a look at this question, you guys will say that, oh, this one is very simple. You guys can actually use the brute force to actually search for the value. Right? Brute force to search for the value. That is going to have the time complexity of O of m times n, with m times n is the size of the matrix. Because you have to search for look at every value in the matrix. So the time complexity would be O m times n, and obviously this one is not an efficient one, because if you guys try to submit this approach to Leetcode, you guys are gonna get a time limit error. So before getting back with the problems, I'm going to revise a little bit about the binary search. Binary search on 1D array. And the requirement for doing a binary search on an array is that this array has to be sorted. So, for example, I have an array of this value 1, 2, 3, 6, 5. You guys can see that we cannot perform a binary search on this array because this is not in a sorted order. So in order to do the binary search, you guys have to ensure that the 1D array is in sorted order. So 1, 2, 3, 6, 7, 9, 10. And now I ask you guys to search for the target value for these number 2. So by doing the binary search, the idea behind the binary search is to reduce the areas for searching. So what I mean by that is that you guys gonna use the characteristic that is the array, or the array is in the in the ascending order. You guys gonna use that one to reduce the area for searching. It is how you guys can do that. Let me bring the target up here. Right. Let's see. You guys have a 2-pointer. The first one is the left at the index 0. Oh, let me also write the index here. 1, 2, 3, 4, 5, and 6. Let's see, you guys have a 2-pointer. So one is the right at the index 0, and the second one is the right at this index 6. So if you guys want to reduce the area for searching in the 1D array, the first thing you're gonna do is find the middle value. This the m would be equal to left plus right divided by 2, and would be 0 plus 6 divided by 2 is gonna be 3. So the middle value is going to be pointing to this one. So what you're going to do here is that you're going to compare the value at the M index with the target value. So if, because 2 is smaller than 6, which means that I mean, when before doing anything, you guys will know that when you pick a number 6 here, every value on the right of 6, which is to this direction, is going to be bigger than 6, and every value to the left is going to be smaller than 6. So that is the very important thing. So as 2 is smaller than 6, you guys know that 2 cannot be to the right of 6, because to the right of 6 is contains of a number that is bigger than 6. Just so you guys can only search for this area. So what we're gonna do next is that we're gonna bring R to M. So now R is not pointing to 6 anymore. R is now pointing to 3. And that's how you guys can reduce the area to search, by performing a divide and conquer, that is eliminate all of those, because you guys know that the value 2 cannot be to the right of 6. So now what you're gonna do next is that also find the middle index is left plus right divided by 2 is 0 plus 3 divided by 2 is equal to 1. So the middle is gonna be here. And now let me erase this one. Alright, so this one. So because you guys gonna need to compare the 2 with 2 here, obviously it's equal to each other, so you guys can easily return a true, because you guys have already found a number. So that is the approach for, the binary search on a 1D array. So how about this problem? Let's have a look at this one again. This one also gives you a searching array, a searching problem with an ascending order. Descending order would work too, but they give you an ascending order here. So it is pretty similar to the 1D array, right? So what I'm going to do here is that let you guys know that we can actually do the binary search here. And let's have a look at this array, this matrix again. We all know that the rows are sorted in the ascending order. So obviously, from left to right is sorted in the ascending order. And when we pick a value 7 here, you guys gonna know that every value on the right of 7 is gonna be bigger than 7, and every value on the left of 7 is gonna be smaller than 7. Similarly, if we guys choose this column and you guys choose a number 9 here, you guys gonna see that the value that is below 9 is gonna be bigger than 9, and value above 9 is gonna be smaller than 9, obviously. So what I'm gonna give you guys a hint is that you guys can have a look at this one. Let's think this whole thing as a 1D array, and you guys will see that we will have a sorted order too. So 1, 4, 7, 11, 15, 19, 22, 24, and 30 is in a sorted order, right? So what I'm gonna do here is that I'm gonna use the idea of the binary search, that is reduce area to search, area for searching. Yeah. I'm gonna use this idea to solve this problem. So now you guys see that we guys have a value of 5. The target value of 5. Let's compare this one. I'm going to do a dry run first, and then I will code later. Just let you guys know what would be the algorithm look like, so that I can explain how did I come up with this idea? So basically, the target value is 5. Oh, let's have another color here. The target value is 5. And when we look at this fact quantity array, you guys gonna see that when we perform a binary search here, just left here, right, left here, right here. So the middle value is gonna be the one in the middle. So it should be something around here, right? So the middle value of this whole array is always gonna be the one in the angle. And what I mean in the angle is 15. So we guys gonna do a comparison. So 15 and 5, obviously 15 is bigger than 5. So you guys gonna eliminate every value here, right? Because you all know that the value in the bottom, I mean below 15, is gonna be bigger than 15. So you guys can remove all of those. Oopsie. You guys don't have to search for this area anymore. And now, since you guys know that 15 is also bigger than 5, you guys gonna remove this one too. And what we're gonna do next is that we're gonna search for this area. So from 15, we jump to 11. So the middle value of, the right value of here is, this color is a little bit hard to read. This one is right here, this one is left here. Oopsie. So the middle value of this fact array again is obviously the value 11. So you guys gonna check again, compare 11 with 5. You guys gonna see that this one is a bit late, number 6. 11 is bigger than 5. So you guys gonna know that every value down here could be eliminated too, right? So what I'm gonna do here is just it's just similar to the previous approach. I'm going to delete everything here, and then what I'm gonna do is search for this array. Where's my highlight on 15? Okay, number 5. So now we have a right pointer here as well. So you're gonna do here is similar to the to the previous steps, that is comparing 7 to 5. So because 7 is bigger than 5, 7 is bigger than 5, so you guys gonna know that we also have to eliminate everything here as well. So let's erase here, also erase number 7. Bit laggy. So what I'm gonna do here is that I'm gonna perform another fact array here with 15 in it. So we jump from 15 to 11, and from 11 to 7, and then from 7 to 14. And the right is always pointing at here. So what you guys gonna see here is that the middle value now is number 4, and is different from the previous values. So 4 comparing with 5, you're gonna see that 4 is obviously smaller than 5. So what you're gonna do here is that I'm gonna eliminate all of the value to the left of 4, because I know that the value to the left is smaller than the value in the right. So I'm gonna remove this one. So erase this one, and also remove number 4 too. Oh, let's remove this one a little bit. So we jump from 11 to 7, and 7 to here, and then we jump from 4 to 5. And here's the special part. So because 5 is also the target value, so you guys gonna return true, since 5 is equal to 5. And that is the idea of the how you guys can optimize the binary search, this problem. Oopsie. That is firstly, you guys have to pick the value at the top right corner is from here. And then you guys have to continuously compare with the target value. If it is bigger than the target value, you guys gonna eliminate the whole column and then move to the next one. And if it is still bigger, then just remove the whole column and move to the next one, and remove the whole column until this one is smaller. Then you can remove the entire row. So the time complexity for this one will be O to the m plus n, because you guys can only delete like the whole, the whole row and the whole column. So the time complexity would be O2 from m plus n, and that's it. So now let's go to the how we can code this problem. So firstly, we're gonna start with the first index. The starting area of us is gonna be the top right corner. So the index of this value is gonna be the size of the row minus 1, and also size of the column, sorry. They're gonna be the size of the column minus 1 and add the row 0. So we're gonna start from the top right corner. In fact, you guys can actually start from this one, because you guys can also form a fact sorted array here with the same idea. So in this code, I'm stuck with the top right corner, so it's just matrix size minus 1 row. This one is to retrieve the size of the row, the size of the entire row, and we're gonna start at the first row. So this one is a little bit pretty similar to the binary search, so that we check value at the top right corner. So if it is equal to target, we can immediately return it true. If it is bigger than the target, we have to eliminate the whole column, and if not, we're gonna just remove the whole row and then move to the next row. And if we cannot return anything, we're gonna return false at the end. And as you can see, the implementation for this problem is very easy, but how you guys can come up with the idea is very tricky, since we all have to know about the binary search. We have to know about how we can mapping the concept from 1D array to the 2D array. And that's it. Thanks everyone for watching this video. See you guys again in another video.